Let's put the pieces of PKI to work, and let's take a look at how certificate enrollment works. Here we actually have a CA server, or a certificate authority server, and a client. The first step is to authenticate the CA server. In other words, trust the CA server, and this is done by downloading the root certificate from the CA server. The process of getting the root CA server installed is often referred to as authenticating the certificate authority server, or the CA. Current web browsers automate this process for well-known certificate authorities. After you have downloaded the root cert, you can request your own identity certificate, and this involves generating a public and private key pair, including the public key portion in any request for your own identity certificate. An identity certificate could be for a device, or it can be for a person. Once you make this request, the CA, or the CA server, can take all your information and generate an identity certificate for you, which includes your public key, and then send these certificates back to you. The client doesn't have to be an end-host machine or a specific user. It can also be a router or an infrastructure device. And it can also be firewalls like the Cisco ASA. The certificate enrollment process is often done using the Simple Certificate Enrollment Protocol, or SCEP. This protocol is used by a lot of vendors, including network equipment manufacturers, software development organizations, who are developing simplified means of handling certificates for large-scale implementations. SCEP is the most popular, widely available, and also the most tested certificate enrollment protocol. Even if it is widely used, many folks are concerned that SCEP, or SEP, is not able to strongly authenticate certificate requests made by users or devices. Let's take a look at how certificate revocation works. Basically, certificate revocation is the process when you actually, for the lack of better word, revoke or invalidate a certificate, and that perhaps has been compromised, or an employee that had a certificate perhaps left the organization or was terminated, or an infrastructure device is no longer in use in the network, or is no longer valid. So in the operation of some crypto systems, usually of course PKI, a certificate revocation list, or a CRL, is a list of certificates, or better yet, a list of serial numbers for those certificates that have been revoked. That's what we actually call CRL. And basically this list are the list of certificates that should no longer be trusted. Let's look at the example that we have here. The client is an iOS device. If we actually want to revoke its certificate, what we actually do is we put in the CRL the actual serial number of the certificate of that router. Now there's a newer protocol called the Online Certificate Status Protocol, or OCSP, that is also available for certificate revocation. There are two different states of revocation. One is called revoked, so the revoked state, and the second one is hold. So in revoked, certificate revocation is irreversible. So for example, if you discover that the certificate authority had improperly issued a certificate, or if a private key is thought to be compromised, or again, if actually an employee leaves the company, that's what you will do. You will revoke that certificate. Now, the hold state is a reversible status that can be used to note the temporary, and again, temporary invalidity of the certificate. So if the user lost the private key, or perhaps a contractor is expected to actually resume some of the activities, but you actually want to put that certificate on hold, you can actually do that as well.